9 years ago when I purchased the C5 Corvette, I only had a basic understanding of how its active handling system works, and I mistakenly thought you could simply just leave it on or turn it off. A short while later, I learned quite a bit more about the technical details of exactly what's going on behind the scenes with active handling and what it can do for you. And here's the embarrassing part. I also learned that if you press and hold the active handling button for 5 seconds, it enters competitive driving mode.
What?
So if you need a refresher on the 3 modes of operation that are controlled by that little button, and when you might want to use each one, then stick around because we're going to do a medium dive as to what's going on behind the scenes when each one of those modes is selected, and we're going to do that next.
Toys for life.
We'll get into the year-by-year specifics in a little bit, but in general, every time you start up the C5, it starts in the default position of active handling on. From there, you can choose to turn it off or select competitive driving. To get a better idea of how all of these computerized enhancements work, I think we need to start off with AntiLock Brakes, or ABS for short, because it's because of AntiLock Brakes that active handling and competitive drive mode are even possible. I believe that by the time that GM and its automotive partners mastered anti-lock brakes, they thought to themselves, how can we improve vehicle performance by utilizing and expanding upon the sophisticated ABS technology so that we're all on exactly the same page of anti-lock brakes for our purposes? Let's go with the following definition. Anti-lock brakes prevent the wheels from locking up during braking on slippery or even ideal surfaces, thereby maintaining some degree of traction with the road surface. It's this traction that allows the driver to maintain much more control over the vehicle versus the almost zero control you would have on the same vehicle if the brakes were all locked up. Through the years, anti-lock brakes have proven themselves beyond a shadow of a doubt, and as a result, every single C5 manufactured comes standard with them. So unless there's some sort of an electrical or a mechanical issue with your ABS system, it's always on, and there is no switch or button in the cockpit that allows the driver to shut the ABS system off. Now let's dig into the main components of the ABS system, because all of them are essential in making traction control and active handling function. Generally speaking, the ABS system has 3 main components. First up is a wheel speed sensor, and each of the 4 wheels has a sensor incorporated into the hub that sends signals letting the next component know exactly how fast that wheel is rotating or if it's stopped. Next up is the electronic brake control module, or EBCM for short, and it is the brains of the system. And what it does is it takes the signals from the wheel speed sensors and it makes a decision as to if some action is required or not. If action is required, it works with the next component in the system, which is the brake pressure modulator valve, or BPMV for short, and what it does is it takes the instructions from the EBCM, and if told to do so, it can modulate the brake fluid pressure to any one of the wheels or multiple wheels if necessary. The next evolutionary step with computerized electronic handling enhancements to the Corvette came in the form of traction control to the C4 Corvette in the early 1990s. According to Motor Trend, every single Corvette made since 1992 has come with some form of traction control. When the traction control system is engaged in the C5 Corvette, anytime it detects that the drive wheels are slipping, it will reduce power by either closing the throttle body, reducing spark timing, and or applying the brakes to the rear drive tires. And if you've ever tried to do a smoky burnout in your C5 Corvette and you've forgotten to turn traction control off, it's likely fallen flat on its face and you've witnessed firsthand exactly what traction control does. Fast forward just a few more years and once again, GM is getting the itch. Anti-lock brakes and traction control systems have been mastered, so the engineers head back to the lab to see what sort of additional handling and safety benefits can be extracted from the technologies. It didn't take them long, and soon GM was ready to unleash the latest advancement in electronic handling wizardry, more commonly known as active handling. Unfortunately, active handling was not ready for the kickoff of the C5 in 1997, but if the purchaser plunked down a little extra cash and checked the box for the JL4 option, it was ready by mid-1998. So what exactly is active handling? Active handling is a system that, when enabled, acts as another layer on top of anti-lock brakes and traction control. The active handling layer is alert and ready to take action anytime there is a significant difference in how the driver wants the car to corner and how the car is actually cornering. And if the system thinks the situation can be made safer, it will take action and apply the brakes to any one of the 4 tires. Now, for most people, this would typically be in some sort of an emergency maneuver where you're swerving to avoid a car or a dog or something like that. Or for people that track their car, this could be any time you're out there and you drive beyond your own abilities. That having been said, although active handling will definitely help in most extreme situations, it's absolutely not foolproof, and it can't always bail you out. So I certainly wouldn't recommend relying upon it, but it's good to know that it's there. Now check out this video from the C5 Corvette's chief engineer that gives a graphic representation of exactly what active handling does.
Now here's an animation developed by our engineering team to help show the performance of active handling. It simulates an aggressive lane change maneuver on a wet surface. The white car is equipped with active handling, and the blue car is not. As the car enters the maneuver, the driver applies more steering input than the car can react to. The car starts to push or understeer. The active handling system senses this and applies the inside rear brake, helping to pull the car into the corner. Once the car is in the left lane, the driver tries to straighten it out, but the yaw inertia of the car causes it to turn more than the driver wanted. Active handling reacts to this oversteer condition by applying the outside front wheel brake. The resulting torque helps keep the rear end of the car from getting too loose. As the driver returns to the right lane, a similar sequence of events unfolds, worsened by the whipping action of the maneuver. The active handling system assists the driver in maintaining control by applying the brakes appropriately. This affords the driver a greater level of control, as well as gradually slowing the car to a more manageable speed.
So how does the active handling system know what the driver is actually intending to do? How does it know when the C5 is turning or cornering? And how does it know, God forbid, if the C5 is about to lose control? Hey guys, just a 10-second plug. I appreciate you're making it this far in the video. If you're enjoying it, please give me a thumbs up. And if you're not already subscribed, please consider doing so. It's not magic, but it is based on some serious computing power that receives more information than ever from 3 all-new types of sensors. First, a steering angle sensor has been added, which tells the computer how far the driver is turning the steering wheel by, you guessed it, just measuring how far the steering wheel is being turned. Next, GM added a yaw rate sensor, which I do believe they stole from an airplane. The yaw rate sensor measures the actual rate the car is turning from the center line. In other words, it's a good sensor to measure the rate of momentum when the vehicle is turning, and if that rate of momentum is extreme enough to potentially cause the vehicle to spin out.
Daddy!
And finally, they added a lateral accelerometer, which measures the side-to-side G-forces that the car is experiencing at any point in time during a turn.
A G-meter? Now, why would an American car need a G-meter?
All of these new sensors are very cool tech indeed. So now that we better understand anti-lock brakes, traction control, and active handling, let's briefly summarize what we've learned and how we can apply it. Number 1, anti-lock brakes. Every C5 has them, and there are no switches in the cockpit for the driver to turn them off, so anti-lock brakes are always on. Number 2, when you turn off active handling, you lose active handling, of course, and you lose traction control, but you still have anti-lock brakes. And number 3, when you've got active handling on, if your C5 was equipped with it, of course you've got active handling, you've also got traction control, and you've got anti-lock brakes. And finally, in competition driving mode, you do of course have anti-lock brakes and you have active handling, but you lose traction control, which is fine because sometimes you just want to do a burnout, or if you're more seasoned at the track, sometimes a little tire slip coming out of the corner can help you get around the track faster. So the next time you take your C5 out for a spin, you'll truly be able to make an informed decision. As for me, more often than not, I find myself putting the C5 in